Hey guys, today I have an Evergreen motor. It's an ECM motor that I'm going to replace in my furnace. It's basically this top part here is a DC motor, and this bottom part is the actual motor controller, a variable speed motor controller. Comes with a little sticker that you can stick inside your furnace with the schematic, so future people working on it know. Comes with a wiring harness, pre-built, some other odds and ends for different configurations. It works for 120 or 115 or 240, 230. I've got the 115 volt plug in it, but it comes with a 230 volt plug. So it's kind of like a universal replacement motor. I'm going to replace this capacitor start motor. It just has built-in 3 or 4 speeds. And I really like these ECM motors. I used to have one on my York Affinity system in my old house. Loved it. You couldn't hear the thing turn on or turn off. You just kind of heard the air blowing out of the vents. And I miss that in my new house here. And this is an old HVAC system, and I don't have the cash to replace it right now. But an easy way to make it more efficient is just swapping out this motor here. Looks like this motor potentially failed in the past. It doesn't look like the original one. It looks like somebody just attached the capacitor on the blower here. Maybe that's how it came, with a piece of that strap. But we're going to tear it apart and retrofit this new motor here. I'll show you the different size and things. And I'll speed up some of these areas with the boring bits. A couple times I use the wrong tools too, so I'll speed through those so you don't notice. But basically just got to pull this old motor out here and get rid of the capacitor. Don't need it. And then we got to pull the belly band off the original motor, and we're going to reuse that on the new motor. Usually these fans come right out, but I had to beat this one out because the previous person that replaced it didn't put that little lock bolt there on the flat on the motor shaft. They actually put it on the motor shaft, and it burred it up a little bit, so I had to kind of beat it to get it out. But here's the old motor. Here my bearings are actually failing in this motor. I didn't even know that. I was just replacing it anyway. Thought it was still good, but perfect timing. We'll just remove the old belly band. Here's where I realized I lost my 1/2-inch open end wrench. And so I had to use a crescent wrench and screwdriver to hold the other side of the bolts. I was being lazy. Should have ran out to the garage, but I was in the basement. And here's the original motor tag, if you care. It's actually a 3/4 horsepower. I thought it was a half. I'm actually replacing it with a half, so I'm going a little smaller. I think the previous people actually increased it to 3/4, because when I previously looked up this model number of my furnace, it said it was a 1/2 horsepower blower. So I think the previous owners of the house upgraded, I guess, went with a bigger motor than they should have. For what reason, but we kind of talked over it, but I was showing where the belly band goes on the new motor. There's a window that you have to get that in, because if you are too far, like in the controller section of the motor, or too far near the face of the motor, there's no real meat there underneath the motor case, so you can actually crush the case by tightening up the belly band. So read the instructions on these Evergreen motors. It tells you the window where you can put the belly band. And I'm sure there's a better way to get these on here. I'm no HVAC expert, though I've done it for off and on for many years as a maintenance guy and in my own home. But kind of just arranged them and where I could slide it down and then snugged it back up. And then you'll see me use the screwdriver as a measuring device. I actually kind of measured on the old motor how far down that belly band needed to be from the face of the motor. And that's what you see me doing when I'm holding that screwdriver up there. I'm, again, wrong tool. Should have got a tape measure, but kind of just went to the shiny spot on the flat blade screwdriver. So we got this all together, nice and tight. Now, when you do put it on, make sure you leave room for the electrical connectors to be between the mounts. You don't want to put them out over the electrical connectors or anything like that. And then going back together is pretty easy. And you noticed previously that this motor is slightly bigger than the original and the shaft is way longer, but the entire motor and shaft fit within a standard blower. These motors are made to be universal fit. So don't worry, you don't have to cut the shaft down or anything like that, or anything to modify it. So this will go right in. Just have a little more shaft sticking out on the other side, but it's still within the blower assembly. Speed this up and throw it back together. And there's a little bit difference with this motor. The speed controller is actually controlled with low voltage. So it uses the thermostat wires, when you call for heat, call for vent, or anything like that. There's a set of wires straight from the ECM motor, from the speed controller, that go to the terminal strips for the thermostat. And that's how you select the different various speeds. And then what I'm doing here is I'm looking at this board. You take the old board used to output multiple 120 volt output signals for the motor for the different speeds. This new motor just has, one wire going to motor to tell it to be on or off. And then it uses the thermostat wires to know what speed to spin the motor or what horsepower. All right, here's the schematic for the ECM motor. You can see it's different than a PSC or a capacitor start motor. Has the power in like a standard motor would, and that's 120 or 240 volts, or line 1, line 2. That's hot all the time to the motor. And then this motor has a high voltage signal. What that is that gets tied to your old fan output connectors on your furnace control board. Normally it would output for cool or for heat or for fan, and those are generally 3 different speeds on the PSC or the capacitor motor. But in this case, you just bridge all those together and send it to the motor. All that does is says, hey, my furnace is calling for blower of some sort to be on. And then the motor defaults to low speed if you have no low voltage signals going in. And then the low voltage signal wires below, those tie to your thermostat terminals, and that's what tells the motor what speed to run at. And it uses low voltage, which is kind of cool. So I tied my yellow to cooling, which is high, my orange to heat, which is medium high. I capped off the brown and I tied the white or low speed to my continuous fan or G on the thermostat wire. I have an Ecobee thermostat, and right now it's set to run, I forget how many minutes per hour, but it kicks on pretty often to circulate air around the house. And again, this is what I loved on my old York Affinity HVAC system I had at my old house. It would just kick on, circulate the air, kick off, and I would never really know. It's so quiet. You just hear a little bit of air moving in the vents. So that's what I did here. Tied the load to the continuous fan. I plan on also tying, I have a pellet stove that I use in the winter to heat the whole house. I'm going to tie that pellet stove's fan output to the G here so that I can kick on the whole house fan whenever the pellet stove is running. And I don't want a really loud blower going and wasting a bunch of power and being annoying. So it'll be running in low speed mode and just enough to circulate that that stove heat throughout the whole house. It's one of the main reasons I've got this motor and did the upgrade. But here, let me show you what it sounds like right up next against the furnace here. Okay, this is all wired up now. This is an old, I forget what brand it actually is, Ultra 5 Tech 80. I think it's Goodman or something. But I just want to show you one of the reasons I switched to the DC. I'm redoing this audio later anyway, so. That's the fan running. You can see it's a slow ramp up and it's very quiet. I'm sure the microphone is amplifying it a bit, but it's very quiet. And then it ramps down as well. If I remove that fan hold, and it's a really long ramp. It just stopped there. But it's very quiet. It pulls way less current than it did previously. I should have took some measurements to show you, but I guess I can take some measurements here in another video and edit it in showing the current amp draw of the new motor. I don't have, like I said, I didn't take anything on the old motor, so I won't have that to compare to, but I guess it's it's set up for half horsepower, so if you have a half horsepower blower, you can measure yours and compare it to what this new motor is drawing. But so far happy with it, except for the wiring I have to do. I need to clean that up a little bit, maybe put a terminal strip in there so I'm not using the actual furnace board as the terminal strip. Kind of have 2 and 3 wires on those little screws, and I don't know. I mean, it's probably fine, but I'm anal, so I'll end up putting a terminal strip in there and landing everything to the terminal strip and having 1 wire to the furnace board from there. Well, that's it for my ECM Evergreen motor swap. I hope you guys found it remotely useful. If so, subscribe. I'm trying to slowly build up my YouTube channel. That'll make me feel like I'm doing something that you guys are actually finding useful if I get some subscribers going. If you have any questions, I know there were a lot of gaps in that video. I left some things out. Post them below and I'll try and get back to you as soon as I can. Include some pictures if it helps you or something. Just let me know. Thanks.